I am going live right now on Instagram. And now I am live on YouTube. So it's all good, baby. I have one, two, three cameras. It's unbelievable. All this recording, just to generate. Mira, ya va, que me metí en el que no era. Me metí en el que no era. Okay, sorry. I need to get out of here. And I need to go to another account. I'm sorry. Yeah, I know. I went on Wollongong Elite.
Oh my God.
Yes. And I'm sorry about that. So I am now live on Instagram. All of a sudden I saw all these people that were connecting. And I said, there aren't many people on this account. So sorry about that. There was a little mishap, which is funny because now we generated that video of me screwing up. So we are on 1, 2, 3 cameras. And it's really interesting because we do generate content that we share online. So hopefully, it's something that will be useful to you guys. So I am going to do something called talk about engineering and reconstruction of the endodontically treated tooth. Now, this is a lecture that I used to give many years ago when fiber posts, were part of the norm. So the lecture talked about why fiber post versus cast metal post. Which one was better, And at that time, the whole idea behind the fiber post was related to modulus and molecular structure. So let me explain that. This is going to be fairly quick and fairly simple. When you have a metal, something made out of metal, the molecular structure of metal is just, it provides certain physical properties, okay? It will. It's just unavoidable. So metals have this property that is called, they're able to conduct energy. They're great conductors. Okay, so for example, if you have a metal cup and you put some really hot on it, if you touch it, you might burn your hands. You cook on metal pots and pans. Cooking on a ceramic pan is a little bit more difficult, requires more time because it is not as good as a conductor of energy, and heat is a type of energy. If you take a metal fork and you stick it in your power outlet, you are going to get zapped. Why? Electricity. The metal will just conduct that energy, all right? Loads, force, it's an energy. And the metal will conduct that. Metal will not dissipate. Metal will not absorb. It will conduct it. Okay? So, for many years, a lot of people used metal post, cast metal post. So, how you do that? Well, you took an impression of inside there. Okay, you did a root canal. You had your root canal measurement. You removed 2/3 of the gutta percha, as long as you always left at least 4 or 5 millimeters of gutta percha in the apex, and then you took an impression. You took an impression of that canal, and then you send that to the lab, and the lab will fabricate a post that was customized to that canal, with a core, and that would be your, what you will be restoring on. You will most likely you use something like glass ionomer cement or zinc phosphate. I remember when I was in dental school, I did a few of those, and I used a zinc phosphate, and that was standard. We were always told that you needed to have ferrule, something called the ferrule effect, for any of these type of restorations to work. And that was the norm. Fiber posts came out, and the first type of posts that came out were carbon fiber. They were really dark gray, not aesthetic, but they came in different sizes. They came in different sizes, and the idea was that there were carbon fibers that were embedded in some epoxy resin. Now, polymers, unlike metals, are not very good energy transmission materials. They don't conduct energy very well. At least the ones that we use in dentistry. You got other types of materials like, but the polymers that we use, like polymethylmethacrylate, epoxy resin, some of the monomers we use, they're not good at conducting energy. They will actually absorb and dissipate the energy. So by having something that will absorb a little bit, dissipate a little bit, transmit some of the energy, but not in full, and now you got something that is more forgiving to the remaining tooth structure. But also, you had something called elastic modulus. The elastic modulus of metal is higher than that of dentin. And the elastic modulus of fiber or composite, resin, polymer-based, fiber posts, their elastic modulus is closer to that of dentin, okay? So now you got things that have similar physical properties, and one of them doesn't transmit the energy to the structure. So, you can make a case for that. You can actually have an argument with somebody. Say, well, this is why I use fiber posts. And I used to have that argument all the time. Saying, I use fiber posts because they have a lower elastic modulus. They don't transmit the energy. They dissipate. And when they fail, it's because they break. But I still have the remaining tooth structure. With metal posts, they do work, but when they fail catastrophically, meaning root fracture. So now you gotta just remove it and remove the remaining tooth structure, and now you gotta place an implant or do a bridge. So there is no saving of the tooth when you have a metal post that fails. What you're going to have with a fiber post is the possibility of replacing that post and putting another post and giving that tooth another chance. So it all depends on how you look at it. It all depends on what it is that you want to do, and if you really, think that you may want to try something like that. Now, this is old thought process. Nowadays, things are changing, but we're going to talk specifically about fiber posts. We're going to do this in two-part event, all right? So let's talk about elastic modulus. I got my little board here. Great. So let's say you have, I'm going to move this slide a little bit. So, okay, brilliant. So let's say you have, your chart here, stress strain chart. And, you start applying a load to something, right? And then it starts to withstand the load, and then all of a sudden starts to deform and it breaks, right? It breaks. So right here, at that point, when you release the load, it goes back to its original position. But there is a point where you're not going to be able, where the material is going to deform and it's not going to go back to its original position. So how do you call this area right here, this part of the slope? This is called elastic deformation. And this area over here is called plastic deformation. That's it, all right? So you got that, right? And then you have, you can calculate all different sorts of relationships right here. So what is elastic modulus? Elastic modulus is the measure of the ability of the material to withstand the load and go back to its original position. So resilience is not necessarily elastic modulus. Elastic modulus is kind of a measurement of resilience. So it's the measurement the measurement of the ability of the material to be, to apply a load to it and go back to its original position. And actually, is the calculation of the derivative of the area under that slope. If you want to get really fancy, which we want here. So there is something called Young's modulus. Young's modulus, which is, it's an E and it's stress over strain, And it's a very simple formula, and you don't need to calculate it. You don't need to do any sort of calculation, because if you call any manufacturing company and you ask for the modulus of elasticity of that material, they should be able to provide you with that information. Now, I'm gonna use an eraser here. So now you know what elastic modulus is. So let's compare different materials. So I got my chart here. So I have something that is like this. High elastic modulus, and then really strong, and then breaks. It doesn't deform, but breaks. And then I have something that is like this, elastic modulus, and then kind of like forms like that and breaks over here. And then you got something that is like this, something like that. So what is this? This top one, a ceramic. That is how ceramics behave. You apply a load to the ceramic, and then it does not deform. I cannot deform this glass. I can only, apply a load until it breaks, it pops. Meaning that it's very strong, has a high elastic modulus, but it's also brittle because there is no deformation. There is no deformation. Here, what is this? This is a metal. This is the typical behavior of a metal. It's the point where it just deforms and then breaks. And what about this one? Really low elastic modulus, a lot of deformation, and then breaks. That's a polymer. So, a metal can have an elastic modulus that goes between 200 and 500, gigapascals. That's the unit. Dentin has a modulus anywhere between 12 and 21 or 20 gigapascals. Some fiber posts have, elastic modulus between 15 and 25 gigapascals. So your fiber post is behaving kind of like this, So when you apply a load to a tooth that has a fiber post, and theoretically, or let's say hypothetically, one of the two surfaces is going to break, whether it's the tooth structure or the post. What is going to break first? Most likely the post. Why? Because the post is less surface than your dentin, your remaining tooth structure. There is no transmission of load. There is no transmission of energy. Even though there is energy concentrations in certain areas, and there's a lot of studies about that, clinical studies show that these things, when they fail, is because they either debond or because they break, but not because they generate root fractures, unlike metal posts. So that's the engineering thought process, how materials behave under certain loads. And there is a lot of information out there, and that's how I used to justify the use of a fiber post. Now, with metal, you don't need to worry about bonding too much. First of all, your metal is really, the interface between that metal and the tooth structure is very intimate, very, very intimate, because you took an impression of that root canal. And then you send it to the lab, and they did the casting of that post. So it's going to fit really well. It's going to have some frictions. And then you use something like zinc phosphate just to fill the gap between the metal post and the tooth structure, or glass ionomer. And that will work. It will hold it in place, and then you can do your core buildup, and then you can do your restoration on top of that. It's going to work. It's very simple. It's very simple. Now, with a fiber post, you have to choose the right fiber post based upon the size, and there are a lot of guidelines. Every company has a different take on different sizes. If you buy RTDs or Ultradents or 3Ms or Ivoclars, or, you can use some fiber posts like Angelus from Brazil. There are many, 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 many different companies that make posts, And these companies will not only make the post, but they will make different sizes, different shapes. For the most part, now we're looking at tapered posts instead of parallel posts. We want something that is more tapered because your root canal is tapered, and that's important, right? And then, you have canals that by nature are wider than others. It's not the same, how wide a root canal on a central incisor is compared to, a lower bicusp. It's very different. And then, what happens is that even if you choose the most, if you're going to use a number 2 post to do a because you're going to restore a specific tooth, and the guideline of the post instructions tell you if you're going to do these type of teeth or these type of canals, you should use this size. It will be more, suited for that space. Even if you try it in and you got some friction, you're going to have a lot of disparity between the walls of the root canal of the post, and the root canal. There's going to be a space. And so because you got no friction, you need to bond. You need to bond, basically, right? So bonding to root dentin has always been a challenge because the root canal leaves the root canal treatment leaves a very complex smear layer. In the past, people used to phosphoric acid etch the root canal. Do you really need to do that? Well, I did it for a long period of time, and after several failures, many failures, I found out that my bonding was not being optimized inside the root canal. And the main reason was not only because of the complexity of the procedure, but because I wasn't able to see very well inside the root canal. How does a root canal look? It's a hole. It's a dark hole. Oh, I got loops. And then it's a bigger dark hole. But unless you have a microscope, with that really powerful light, you can actually see they're going to put you at the apex. Yeah, you can. If you have loops, I don't care how powerful they are, it's very unlikely that you're going to be able to see very well inside the root canal. So if you start thinking about etching, how do I etch? How do you know when you inject the etch, it goes all the way down? How do you know you're removing all the etching? You don't know because you can't see. How do you know you're leaving the walls of the root canal with the proper moisture for your adhesive? You don't know because you can't see, And then how do you know you're properly applying the adhesive? Oh, I do it by feel. Well, you're being blind. You're working and blindly. How do you know you left the right amount of adhesive on the surface? How do you know you didn't leave any spot that you didn't cover it properly? Because you can't see it. You think you did. So, how do you know you accurately remove the excess? All the excess of the adhesive. How do you know you properly polymerized all of this? You don't know. You can't really see it. Unless you have a microscope again. And if you do, great. I used to work with a microscope. I had a microscope in my office. And I thought, well, I think that with a microscope I can do a better bonding. And yeah, you can, but I ended up teaching and showing my endodontist how to place a fiber post. And it became much easier. He knew way more about than I did about root canal anatomy, which root canal to use and why, and Also, the isolation, he was very good at that. So he was placing the fiber post under isolation, which I think it's very important because bonding requires good isolation, one way or another. So the endodontist is very good at isolating one tooth, so he's going to place a post, boom, done, And then new materials have started to come out, more convenient stuff, stuff like self-adhesive cements. So now we got cements that will achieve bonding to the post because they're resin-based, but also achieve some kind of bonding to the root canal in combination with a little bit of retention. So now all I need to know is that that cement will properly fill that root canal. And then I place my post, and that post, that is just going to, as you immerse it in the root canal, the excess cement is going to flow out. You're going to clean it. You can cure that cement, at least in the most coronal part of it, but you can rest assured that it's going to polymerize because it's dual cure. People say, I cure through my fiber post. How do you know the fiber post is an extension of your curing light? I read an article, like, I wouldn't trust a fiber post to be an extension of my curing light. The fact that you put it next to the light and then you click on the light and the fiber post turns blue doesn't mean that the fiber post is transmitting the proper intensity and energy. It might transmit some. I'm not saying it will not, but it will be enough. Do all fiber posts behave the same? Do all curing lights have, the transmission of energy that is required to be passed on a fiber post? It's too many variables, So I would be kind of like not leaning towards using my fiber post as an extension of my curing light, like a light probe. I would rather trust the self-cure mechanism of a dual cure material. So I inject a self-adhesive cement and I'm good. So your bonding is actually fairly simple because you take your fiber post, you apply some primer to it. You don't need to etch it. You don't. All right. So when you try it in to see the fitting, you take it out, and then you can use maybe some alcohol just to remove whatever, to clean it. And then, you dry that out, and then you apply an adhesive, but you need to light cure it before you put it inside. Make sure you air thin it, whatever. You got to do it. But you can also use silane. You can use your silane on top of your post. Let it dwell, let it do whatever it's supposed to do for whatever the instructions tell you, I will highly recommend that every time you silanize the surface, you leave it there for 3 minutes. Or after you silanize, depending on the moment in your bonding procedure, you can use hot air to make it react faster. It will be like a catalyst. Your bond strength is not going to be better. It's just going to be faster. You're going to achieve it faster. And then, you inject your dual cure cement inside a self-adhesive dual cure cement, and then place your post, and you're good. Now, on the core, the area of the core, you're going to have to do your bonding, enamel, dentin, whatever, and then you place your core builder material. That's a totally different thing. Now, what is the main use of a post? To serve as retention for your core buildup. That's it. It is not to strengthen the tooth structure. It is not. The main purpose of a fiber post is to serve as an aid for the retention of your core buildup. That's it. That's why you would use a post, to have more retention. Now, what's interesting is that you think about Well, what if I don't want to use a post? Can I get away without using a post? The literature is showing that you might be able to do that. And that is more of a interesting trend that's going on. This, no post, no crown trend, which is fine. There is literature to support that. People are talking about, well, I don't need to place a post. All I got to do is use bonding to hold on to that tooth. And that's an interesting approach. Guys like Pascal Magnier and his followers are talking about this, and you got a bunch of people who are doing this on social media, and you got a lot of people who are talking about this, and it's an interesting topic. Do I recommend the use of fiber post? I think that we're moving because the bonding is getting better. I think that this is an interesting take. Is there going to be a moment where I'm going to say, you don't need a fiber post? Maybe. I think that maybe even if you have ferrule, if you don't have a lot of remaining tooth structure in the coronal area, you might need something to help you in the retention of, the core building material. Do you need to personalize the post to that root canal by using like composite and to make it more the contact more intimate? Personalization of a fiber post. I never did that, but there are different takes on this. What I want you guys to take from this video today, is that fiber posts are available. They have a place and they can be used. But to do bonding inside the root canal might seem unnecessary by using a traditional method. There are so many problems that can happen. How do you know that you're properly polymerizing your bonding agent? Oh, Rolando, I use a dual cure adhesive. Great, but not everybody has access to that. Using a dual cure adhesive. Do you have a dual cure adhesive that it's self-adhesive or a universal dual cure adhesive? There are some out there, but those are rare. Usually people have only light cure adhesive. So going deep 10 millimeters inside a root canal and trusting your curing light to be able to cure that adhesive all the way down there, that's a stretch. That is a stretch. So by using a self-adhesive cement such as Reliax U200 or Unisem, depending on where you're standing, Theracem, Reliax U200 or Unisem is from 3M, Theracem is from Bisco, that's a wonderful cement. You have also Biscem from Bisco, you have Speedsem from Dentsply, you have things like Maxim Elite from Kerr, Parasem. Well, Parasem is not self-adhesive, that's from Colteen Weldon. You have a bunch, so many out there, self-adhesive cement. Panadia SA. Those products will work fine as long as you add some kind of primer to your post, whether it's an adhesive or silane or even your MDP containing zirconia primer can work because they're monomers. All of them will work. And then you do your bonding. Which one is preferred? Well, I think that based upon some of the testing I've done, I haven't seen a lot of differences. So for what you really needed, it doesn't matter, and we're not talking about optimization of bonding. We're talking about the way to do bonding in a dark, deep place. What is the best way of achieving a proper bond? If you ask me, can I bond to dentin by etching it and all of that? And I'm like, yeah, you can, but it's so deep that you may not be doing it properly because of the limitation of the place where you're trying to bond. Oh, but it's better. I'm not saying it's not. It's just more difficult, more cumbersome. So something is going to give, okay, I can't reach that area. How can I bond in a dark, deep place without having to think about, did I cure properly? Did I etch properly? Did I deliver the adhesive properly? Well, self-adhesive cement will do the trick. There are articles out there that talk about this, and I remember I went to a lecture by a professor from University of Berlin. Her name is Kirsten Bitar, and she gave an excellent presentation on how self-adhesive cement are probably the most reliable materials that you can use. And she was using a specific brand, which is fine. And she said, this is the one I use because this is the one that is provided in the school. But she tested others, and others seem to do the work, and that's fine. Now, what you do on top of the post in order to do your core buildup, that you have to properly bond to the remaining of the tooth structure, and also making sure that you have ferrule, the ferrule effect, you're going to be fine. The debate is not whether you can use a post or not. In this presentation, the debate is, do I need to use a cast metal post? And do I really need to do bonding inside the root canal? Bonding from a traditional point of view. So I will leave you with that thought process, and you can ask your questions, okay? Depending on where you're standing in the world, some countries or some dental communities are more conservative. They would rather just use cast posts, which is fine. It's just that there are limitations based upon molecular structure and physical properties. That's it. I'm not saying you shouldn't use them. I'm just saying that fiber posts are more forgiving to the tooth structure. Way more forgiving. Absolutely. And that's the way I see it. Whether you disagree or not, that's fine, but that's the way I see it. And this is my message. If I had to choose between, let's say right now, we have decided that we're going to place a post and make and do a core buildup for a restoration. Which post would I use? Cast metal or fiber? Fiber post. 100% of the time. I will not use a cast metal post. There's no need to do that. As long as I have how to bond on the coronal part, I'm good. I haven't used a cast metal post even like I graduated from dental school and maybe did one or two, and then I never did any more. And you will hear people, that's the only thing I've been doing, and that's fine. It's like that guy who doesn't have a scanner and tells you, I've been taking impressions with silicone forever. Okay, but if you have a scanner, that is easier. Does it work for everything? Maybe not, but it does work for a lot of things. So evolution, fiber post is just an evolution. And now we're getting to the point where fiber post may be a thing of the past. So we're not even thinking right now about whether it's metal or fiber. We're thinking about just removing the need of any sort of post and having to finagle with the root canal that is sealed, that you don't want to touch. And root canals now are even more conservative. So you have to think about post preparation, using those burrs, removing unnecessary, going through the unnecessary removal of dentin inside the root canal. So you have all these things, all these nuances that become all of a sudden limitations in order to do a more conservative treatment, even on a root canal treated tooth. So to wrap it up, first part of this lecture series, between a fiber post and a cast metal post, definitely a fiber post. Why? Because you can bond to it, you can be more conservative, and you don't actually need to go as deep as you should with a metal post. You don't, right? You don't need to go, just leaving 3 or 4 millimeters of gutter per. Nope, you can do just half of the root canal, and you're going to be fine. You're going to be fine. You're going to be fine. So I wanted to leave this information here. The next presentation we're going to do, we're going to go into the questions that I know you guys are going to have, and eventually we will go more in detail through several of the steps, the core buildup, and also the different treatments that we can try on these type of materials, and what can you do on top of that. What can you do on top of that? What kind of restoration you can use? So I just leave this here, and hopefully it will serve you guys. And I know you've had some problems downloading the last article that I left there. But, you know, I just looked at it at Patreon and I was able to download it. Just click on the link. So if you're having issues with that, shoot me a note and I'll see what we can do. Maybe I can forward it to you, or maybe we can find another way of posting it. But that's the way I did it, and it turned out fine. You know, it's kind of like a little Dropbox thing. You know, put it in Dropbox and you click on it, download it. It's there. It's embedded. It's embedded. You know, it's there. It's a file. So you guys, thank you for, you know, listening to this video. If you have any questions, just shoot the question. I'll be more than happy to provide you with an answer. Another thing, take a picture of this, do a screenshot, post it on your social media accounts. I will appreciate that. And then, you know, tag me and I will share that. And this is what social media is about. And we're trying to grow our community, or at least I'm trying to grow this community. My community in Spanish is growing at a different rate, a different pace. But this one is, I'm going to keep it. I'm going to keep on nurturing it. And, you know, we're kind of making history here, having fun. You guys take care. Thank you for listening. It's always nice.